we have enough battery for that. Otherwise, I got my cell phone over here. Okay. So, great. So let's begin. I purposely went off the agenda board because I don't want you to copy the homework. I haven't decided what I will give officially because we got through less in the other class, so I'll tell you. In the meantime, let's start with this warm-up. You may use your calculator when appropriate, so you have to figure out if you need your calculator, when to use it, okay? Let me give you about 2 or 3 minutes. Notice what mode you want to be in, what kind of answers you want to give, what the domain restrictions are. So please, working with your group or your partner on these 2 questions. What kind of answer I want. So remember, when every time you take out your calculators, just check your mode so you know what you are working in, and maybe you have to change it. Okay. If you have Desmos out already, you should also know how to do this on your graphing calculator, right? You want to be able to be skilled in that part as well. So both answers, note one is in degrees, one's in radians. Make sure yours are also in the appropriate mode. When appropriate, if it can be in terms of pi, yes. If it's a pi-able answer. Things you might want to take note of is how many answers you should have. Make sure you have that amount. Figure out how many you should have based on your original question. I'm going to give you about 30 more seconds to work and get as far as you can get.
What you give the first one? The second one, what did you do? Yeah.
Okay, if you haven't talked to your partner yet or group, turn and check in with them, see what they have for answers. And I'd like to hear you talking, so I can hear what good answers you have.
What did you guys get for the first one? pi over 4 and 3 pi over 4. This is in the domain. The restriction for cosine, inverse cosine, pi 0 to pi, right?
All right, first one, let's talk. I see this is what I see on people's pages, and then I see an answer. What is the answer to the nearest tens place? What do you have for an answer? You can call them out. What do you have? 4.1 degrees? Good. Is that our only answer? No. Julia, why not?
Sign's positive in 2 places.
Good. Sign's positive in 2 places, right? So what quadrant are we in for this output answer when you solve for x, guys? What quadrant does your calculator give you? 1, right? So we're in quadrant 1. Here's 4.1 degrees, right? Where else is sign positive? Because this is a positive value. What other quadrant are we in? 2, right? So we actually have this one over here. So draw your sketches. Those are super helpful. So we have 4.1 degrees, and then the other angle would be what? 100 and... Great, 175.9 degrees. Okay. Now, what was my domain restriction on this? What did I say? What was the domain restriction? What is it? Hannah, what is that? Oh, okay. You shook your head. So what's our what's our domain restriction? What does it say over here? Can you see? Ben?
There is none.
There is none. So there is no domain restrictions. The one we did before, all of the last block and last night for homework, domain restrictions. So what's missing from here? What's missing from here if I'm not terminating it from 0 to 2 pi? I'm not cutting it off. Ben?
You have to add 360n to it, which n equals any number.
Yes, right? So we're talking about all the coterminal angles. So we're going to add 360n, where n's an element of the integers. We are going to agree this time not to have to write n as an element of the integers for right now. We're going to make the assumption that we're all going to say the same thing, okay? Do I need a plus or minus on this? Do I need a plus or minus? No. A few people had that on their quiz. You don't need the minus because n by definition has the negative set of integers, right? Good? Okay, so here's our answer for the first one. Now we're on to our second one, and I see this on a lot of pages. What do we do next? Tell us what to do next. Who wants to make a guess as to where to go next, or what did you do next? Kyle?
You split into positive and negative.
So we can split this into positive and negative, so we can go plus or minus. Is that good? Plus or minus, because there's absolute value. What else can you do on that right side now? What else can you do on the right side? Kyle?
Rationalize.
Rationalize it. If you didn't rationalize it and you typed it right in your calculator, I want you to undo that calculation you did in your calculator and get a more exact answer from your calculator without your calculator. What is this when you rationalize it? What do we get? Cosine x is equal to
Plus minus root 2 over 2.
plus or minus root 2 over 2? Great. Can we get exact values, exact radian values now? Yeah. So what do we have? Shannon, what do you have? X equals?
Pi over 4
Mm-hmm.
and 3 pi over 4, 5 pi over 4, and 11 pi over 4.
One too many. 7 pi over 4. Is that good? 4 answers? Okay. What are we going to add to all 4 of these folks? What are we going to add? Plus
2 pi n.
2 pi n. Great. So 2 pi n is an element of the integers. We're going to assume that. Great. 2 pi n. This is really low. Can everyone see that? Are we good? Okay. Is there another way to shorten this up? Here we have all our answers. I'm going to draw over here so it's not so low. I got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Can we trim this up and write it even shorter, condense it a little bit so that we don't have 4 answers? Jane?
N pi over 4 and n is an element of odd integer.
N pi over 4, where n is an element of the odd integers.
Positive.
Positive odd integers. Okay, so changing the restriction. Okay, so changing that restriction, let's go up here. N pi over 4, where n is an element of the odd integers. Okay, so let's say that we actually will not change the restriction. Okay, so like on your quiz where I gave you a restriction, you don't want to change it. So yes, that's good if we change it. That'll work, because we'll have 1, 3, 5, 7, we just keep going. Does that make sense? Okay. What if I say I still want n as an element of all the integers? There is a way to trim this up even more. What can we do, Hannah?
Is it like pi over 4 plus n pi over 2?
Why n pi over 2, Hannah?
Like it's adding 90 degrees.
We're adding 90 degrees, or we're adding pi over 2. Does everyone see that? Here's pi over 4. What's the difference between pi over 4 and 3 pi over 4? What's that angle measure? 3 pi over 4 minus pi over 4 is? Can I go 2 pi over 4 first? And then go pi over 2? And then we could convert it to 90 degrees, but let's talk radian values first. Does that make sense? Are we good? So we could trim it up this far where n's an element of all the integers. So then we're going pi over 2 plus pi. Does that make sense? Okay, so that's another one. There's one more common one we'll see, and I'll take all of these answers, okay? All of them are totally acceptable. That's what you're going to see. So one more, I'm going to slide it in here. If I have pi over 4, okay? So if I have pi over 4, and we add pi to it, we get 5 pi over 4. Apologize if you're with me so far. Good. And I can keep adding pi n, and we're still going to land back at pi over 4. Does that make sense? So we could add a pi n, and then take care of 3 pi over 4 separately, because at 3 pi over 4 we can also add pi n. Is that good? I want you to see this one because this helps for something that comes up next when we graph other ones or talk about other ones. So all of them are totally acceptable. If I don't want to change on the restriction, I don't want this one. Okay, if I say n is an element of the integers, these keep them all integers. This changes that. Okay? Questions? Sure? Okay, so at this point I want you to open your Chromebooks. So part 2 for today is to take a look at some nice trig graphs, specifically sine, to start off with. Okay, the other day we did the notes, A, C sharp, and we saw how sine will change, the max and min values change, and then the number of times you see sine. Okay, so does everyone have Desmos up right now? You specifically want to focus sort of in between 0 and 2 pi. Okay, so 2 pi is approximately how much? 6.28. Yeah. So maybe put your cursor on this 6.28, or you can change your window. It's up to you. But since we talk so much about the period from 0 to 2 pi, that's going to help in terms of what you're looking at when you're on Desmos. Is everyone there? So here's the graphing that I would like you to analyze. So you're going to sketch these 2 graphs all on Desmos. Okay? So we have y equals a sine x and y equals sine bx. I would like you to change the value of a. Okay, pick any numbers you want. Make them positive, make them negative. I would like to know what happens when you change that a. And then you're going to do similarly with the b, only keeping positive values for b. Okay, no negatives in there. Okay, go ahead. About 2 or 3 minutes. Write down what you see, what happens when you change the a. Make sure, I think you might want y equals in there.
That says too many variables.
Well, you are picking values for a, or you can define a, right? It's a slider, you can make it a slider, or you can actually plug in numbers and put in 2, 3, 4. It's up to you. Okay. So a little bit of this is finagling Desmos, right? We've worked with it quite a bit, but I want you to just kind of work with it in a way that works for you. Talk to your partners, see what they have, check with another group.
So when it is negative, it flips.
Yeah.
It would be if it were positive.
It might be nice to see multiple graphs together, like y equals 3 sine x, 4 sine x, 5 sine x. Some of you would like that over a slider. It's, you know, pick and choose or do multiple different things.
You just click on.
Oh, you clicked on each one separately and I see it. Min max, I'm sure there's some sort of. Yeah, sure. No.
Would you describe
Definitely.
what happens when B changes? Yeah.
Good. Quinn, how's it going?
Good.
It goes from negative half, so like I've been signed to in a period, and then
Take some notes on your paper about what happens with
So the
A,
closer it is to
what
zero,
happens with
the
B.
farther apart they are, but when you increase it,
yeah,
either
so like
positive or negative.
when I put 2 in the period, and now twice as short. Or yeah, because now it only goes from 0 to pi before it makes the full like. And to get to 2 pi, it goes to yeah. And then I do like the full. And now like that's what I'm going to do. So it's like go to
Let's get another word for that.
okay, yeah.
We say it stretches it,
Goes whoosh.
or it makes it wider. It doesn't, because it stretches it, it either makes it wider, or it stretches it, do you know what I mean?
Welcome to Sniper.
Okay, let's take one more minute maybe. Show your partner what you have written if you haven't checked in with them, or talk to them if you haven't, see what they've written, swap papers.
Maybe large scale.
Is that, do you need another book?
Uh,
I got more.
yeah. Maybe one or
on
two.
each side?
Yeah, one on each side. Thanks.
We have more if you want to.
No, that's fine.
Okay, once you're ready, put your lids down. That'll tell me you're good to go. Remember, we want to look between 0 and 2 pi. That sort of helps us zero in on something. Okay, let's start talking. So tell us something about A. One thing about A. Jordan, what do you have? What does, when you change A, what happens?
Well, like, when A is negative, it like reflects over the x-axis.
Great, so when A is negative, it reflects over the x-axis. Good. What else happens when you change A? What else happens when you change A? Robbie, what else happens?
The points at the quadrantal angles get higher, so it's
The-
Steeper.
Good, so the points at the quadrantal angles get steeper. What do we call those points? Can we name them something? They're not just the quadrantal angles at zeros. I think we're talking about something else. Where is it happening on the graph? The vertex? We don't call it a vertex. Starts with it. I think if I'm with you, we're talking about things that start with M's. This and this. M.
Min and max.
Min and max. Is that what you're talking about? Like the highs and lows, or the trough and the valley, the crest and the trough? So not just the zeros. The zeros aren't changing, actually. It's how high or low it's going, right? So I'm going to call that the max or min values. The max or min values. We actually defined this term when we started this unit. What did we define the term? What's the name of this thing that's changing? It's the what?
The amplitude is multiplied by the factor A.
Good. The amplitude is multiplied by factor A. So normally, with a just plain simple sine graph, A is equal to what value, folks? A is equal to 1, right? We will go up 1, down 1. But when we put a coefficient in front, it changes it. If we make it negative, it flips it. Think about a quadratic. Negative x squared, flips it, opens it down. Lines go down versus going up. So all of the same rules sort of apply. Dodgers, if you're with me so far. So it's down now. I think we're good with that. We don't need the Chromebooks at this point, I think. What about the second one? Sine bx. What happens when you add a b in there? What happens when you add a b in there? What's the change on the graph going to be? What happens when you add a b? What's the change on the graph? Emily, what do you have?
Would be the height, but the range doesn't change.
Range does not change. So it does not change the range. Does not change the range. Good. It changes something though, doesn't it? When you have a number in there, what happens? What changes? Shannon?
Changes the frequency.
Changes the frequency. So the frequency changes. What's frequency mean?
It's like how many, you like take one period and condense it more.
Okay.
So you have more periods.
You're perfect. You have more periods. I'm going to put this in parentheses. More periods between, and I'm going to focus on the 0 to 2 pi. That's sort of our area to start with. Okay. So if we increase that number, then the number of times you see the sine graph increases. Does that make sense? Okay. What else does B do? What else happens with B?
The number B is the number of periods that are going to be between 0 and 2 pi.
Yeah, so the number B is the number of periods. It's how many times it's going to be between 0 and 2 pi. So we've got the word frequency, we've got the word periods. Repeat what you said one more time, Ben.
So the number B is going to be the number of periods between 0 and 2 pi.
The number of periods between 0 and 2 pi. Okay? Good? Okay. So let me ask you this. If you see sine 2x, this is all going to be verbal, no writing, sine 2x, y equals sine 2x, how many sine graphs are you going to see between 0 and 2 pi? Sine 2x, how many sine graphs are you going to see between 0 and 2 pi? Call out your answers. How many do we have? 2. If you have sine 3x, how many sine graphs are you going to have between 0 and 2 pi?
3.
If you have 4, how many are going to be there? Sine of 10x, how many are going to be there? How about sine of 1/2 x? 1/2. There will be half the sine graph, right? So if it's sine of 1/2 x, between 0 and 2 pi, you're only going to see half the sine graph. Does that make sense? Are we good? Okay. Let's put them all together in terms of one equation. Can I move this forward? Are we good? One equation that puts the a's and the b's together. Okay. So, in summary, we have these two things that we just talked about. We'll put them all together. Y equals a sine bx or cosine. Remember we talked about sine and cosine together because they have the same period. They're both from 0 to 2 pi. They're just a shift, as we've learned and talked about before. A discusses our amplitude, right? A positive means it opens up or starts up like our normal sine graph. However, if it's negative, we said there's a reflection, so it opens down. Kind of like quadratics. They open up or open down. Think in the same format, right? You want to build on what we know already. The period, or the amount of times this happens, the frequency is how many times it will happen. The period will tell us what the distance will be to see one complete sine graph. Okay? So b is the number of times it happens from 0 to 2 pi. So if we want to know what a period will be, 2 pi divided by b. Andres, if you're with me so far, we'll do an example, okay? Just some new terms. You bring pens and pencils down then at this point when you're ready from this slide. So when we first started this unit, I asked you what the highs and lows were. I think Ryan said we have a trough and a crest building from science, right? So here's another sketch. Can you see that yellow graph really faintly in there, right? The amplitude is from the middle axes, that axes, up or down. We've got the crest, the trough, or the mid, or the max. We said concave up, concave down, smiles and frowns, all ways for us to get our sketches. Our period is from crest to crest, or trough to trough, right? We've been only working from 0 to 2 pi, and now we're going to shift off of that. So looking at a graph, we can determine the period based on landing at the same y value. Is that good? Questions? So, what's the amplitude for each? You can call these out. I don't think you need to write anything down. Up to you. Amplitude for each. Y equals cosine x. What's the amplitude?
1.
0 or 1? 1. There's always going to be a number. If it was 0, what would the graph look like? Nothing, right? So a line maybe is not going anywhere, so it has to be a number. So the amplitude is 1, okay? What about the second one? What's the amplitude?
5.
What's the second one? What's the next one?
5.
What is it?
5.
5. Where does it start, though? This graph starts at where?
-5.
When I say where does it start? At 5, -5, 1, -1, where does it start? On the y-axis. -5. Is that good? Amplitude is still 5. The sign just changes how we start the graph. Okay? Okay. Next slide. So what's the period? Maybe this one you want to write down. I think it's totally up to you, but this might be a place you want to see it. Sin x. What's the period for a simple plane sin x? That's our basic family. The period is what?
2 pi.
2 pi. Are we all on board? 0 to 2 pi gets us one nice complete sine graph. Okay, so the period's 2 pi. Sine 2x. What's the period going to be for sine 2x? So I'm thinking to myself, from 0 to 2 pi, I'm going to see the graph this many times, which means the period is going to be this many times.
Pi.
That's what I'm thinking. What are we at?
Pi.
Pi? Pi or 4 pi?
Pi.
Pi. So how many times are we going to see the sine 2 graph? 2x, excuse me. Hannah, how many times are we going to see this graph? From 0 to 2 pi? Twice, right? So here we go. That means I'm going to see the graph like that. The briefest of sketches. Does that make sense? So half of that, Hannah, is pi. So our period is pi. 2 pi divided by pi. Excuse me, 2 pi divided by 2. The period, in order to see one complete period, is half the amount of time, not double the time. Okay? Let's do another one. The period is pi. Sine 3x. So in my head, I'm thinking, God, I'm going to see this many graphs from 0 to 2 pi, which means the period will then be working backwards. What do you think? You can call them out.
2 pi over 3.
2 pi over 3, right? 2 pi over 3, so we're going to see it 3 times. The frequency from 0 to 2 pi is 3 times. Okay? 2 pi over 3. Sine of 1/2 x was the period for sine of 1/2 x. So I'd see this many of them. Going through this, what do we have? Hands up for this, don't call this one out, give everyone a chance. Sine 1/2 x, what's the period going to be? Allison, what do you have? 4 pi. How do we like it? 4 pi? Yes. 4 pi. We'd see half of it from 0 to 2 pi. So we will use the reciprocal. 2 pi over 1/2 is 4 pi. How about sine of x over 4? Raise your hands with an answer for that one. Sine of x over 4. 8. Thanks. 8 pi? 8 pi? Good. We got it? Okay. Let's draw a sketch. So now we know how to find the amplitude, how high or low this graph will go. We can figure out what the period will be. So let's go ahead and make a nice sketch. Okay, so we're building off of our previous sketches for sine. I'm actually going to move off this board because can't fit it all there. So everyone have that written? -4 cosine 3x? I'm going to go off there. what I have, negative 4 cosine 3x? Good, okay. So we're going to start here as our first one. We're just going to go from 0 to 2 pi, okay? So just as we did for sine x and cosine x, we're going to start with 0 to 2 pi, and then we'll build off that, and I can ask you for more, okay? So we're going to use all our knowledge of how you graph a cosine graph, okay, at equal intervals. And key values, we've said there are 5 key points for every period that we draw, right? We had highs, lows, and zeros in the middle. So what's the amplitude for this graph? The amplitude is how much? Let's talk. You can just call out. What's the amplitude? 4. So our amplitude, the amplitude is 4, okay? Are we going to start up high or down low? Low. So I'm going to just say that there's a reflection here, making this note for myself. There's a reflection, so I know to start low, okay? And then what's the period for this graph? The period is how much? What's the period? The period is equal to?
2 pi over 3.
2 pi over 3. So it's 2 pi over b, and the value for b in this case is 3. So this means that one complete cosine graph will arrive between 2 pi over 3, from 0 to 2 pi over 3. Okay. So how are we going to graph it? Okay. We're going to go from 0 to 2 pi and cut it in half, cut it in half, cut it in half. Okay. So what do I mean by that? Actually, let's make this one 0 to 2 pi over 3 to start. Let's do that. We'll do one period, and then we'll do another one. Okay. So we're just going to think about our cosine graph. We've got 5 key points. So how do we do that? We cut it in half, cut it in half, cut it in half. Here we go. From 0 to 2 pi over 3, if you cut that in half, it's 2 pi over 6, which is equivalent to pi over 3. Yeah? And then we want to cut that in half and cut between pi over 3 and 2 pi over 3 in half. So between 0 and pi over 3, we got pi over 3, cut it in half is pi over 6. All about the fractions, right? So it's 1/6, right? 1/3. And now we just want to make sure we're equally spaced and we have the appropriate fractions. I expect these exact values to be on your grid, okay? So this is 1 pi over 6. If you add another, you get 2 pi over 6, which is pi over 3. Yeah. And then another pi over 6 is 3 pi over 6, which reduces to pi over 2. You see how we did that? But 3 pi over 6 plus another pi over 6 is 4 pi over 6. Bingo, I got it. I got the right fractions. Does that make sense? So maybe over here I'm like 1/6, and then I'm like 2/6, and then I have 3/6. I have a little note to myself about what those fraction values are, but we want simplest form on your grid. Okay? Most important values. Now let's plot the rest. Highs and lows. So we're up at 4, down at negative 4. And then we said cosine starts at negative 4, so we're going to go down to negative 4, and then go every other one. Okay, so down low, in the middle, up high, in the middle, down low. And then we're going to do smiles and frowns. Concave up, concave down. So we've got a smile, a frown, and a smile. Concave up, concave down, concave up. So the toughest part, I think, will be these fractions in here, right? The rest is the same. The graph is the same. We just need to make the highs and lows and start in the right place. It's these intervals. Okay? Questions? Right below it, let's go ahead then and go from 0 to 2 pi. Okay? Make it really long. Give yourselves plenty of space. Okay? Space is the issue here when we see some mistakes. So 0 to 2 pi over 3. I'm going to make it very long. But again, all I'm thinking about is cutting things in half each time. Okay? So from 0 to 2 pi, we said there will be three cosine graphs. So I'm going to cut this into thirds. Is that good? I just said we cut everything into halves, and now I'm cutting into thirds. I want to land how many there are. There will be 3. We said that the period is 2 pi over 3. So I have 2 pi over 3, 4 pi over 3, and another 2 pi over 3 gets us back to 2 pi. Nadja, if you're with me so far? Questions? Okay. And now I'm going to change colors just to highlight, because this is where we have to cut things in half, and that's it. Cut this in half, in half, in half. Once we figure out what each interval is, it's just adding all the fractions, right? So again, 2 pi over 3, cut it in half is pi over 3. Cut that in half is pi over 6. So this is so nice because it starts at 0, and the first interval is 1/6 pi. Now I'm just going to add 1/6 pi all across the board, right? So 1/6 pi, 2/6, 3/6 is pi over 2. 4/6 is here. How we doing? You gonna talk to me? Are we doing okay? 4/6? Yes, nod. So fourth, sixth, then we have 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 reduces, I'll reduce that in a second. 10 pi over 6 reduces. 11 pi over 6 reduces. No, it doesn't, thank you. I'll leave that. And then 12 pi over 6. So 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And so all we did was add that equal interval, 1, 6, 1, 6, 1, 6. Good? And now highs and lows, we're starting low at -4, up at +4. So we'll go, our starting point's the biggest thing, and then start in the middle, low, in the middle, up high, in the middle, down low, in the middle, up high. Yours should look really nice. Mine look like they're getting scrunched together here. And then concave up, concave down. This is very mechanical, right? We just need to be able to find the fractions and then slide our graph right in, knowing the amplitude. Questions, guys? Okay, let's do one more. So this is example number 1 for this one. Let's do a second graph. Are we good here? Can I move up? Sine. We want y equals. Walk back and forth again. 3 sine pi over 2x. 3 sine pi over 2x. 3 sine pi over 2x. Ready? Great. Started with your partner. What's the first thing we started finding? We found the what and the what? We found the amplitude and the period. Good. Talk to your partner, find the amplitude and the period. What?
Is the x inside the sign?
Oh, this whole thing is attached. You can assume multiplication with no parentheses, so this is all attached, yes. Okay, good. Okay, what's the amplitude, folks? The amplitude is 3. What's the period? The period is
4.
4. A nice plain 4. Because it's 2 pi divided by pi over 2. What happens to the pi's? Cancel. So our period is 4. This is super nice. These are nice values. Let's go ahead and graph them. Is there a reflection about the x-axis for this one? No. So let's show one period. I have no directions on the board. So let's show one period here. We'll just make a note. Okay. I will tell you what I want, so I have to tell you, otherwise you don't know how much to give me. So we're going to go from 0 to 4 instead of 0 to 2 pi or any pi value, because our period is 4. It can be a nice value integer. It doesn't have to be in terms of pi. And then we literally cut them in half, half and half. What's each interval equivalent to? 1. So nice. So 1, 2, 3, 4. Our amplitude is 3. And so, nice graph. All integer values. What about the pi over 2? What's the pi over 2 help us with, Hannah? What's the pi over 2? What's this number that's next to the x, our b value? We started off by using Desmos for this. What does the b value tell us? The b value, can someone jump in? Anyone can jump in? B value tells us what? Frequency. The period. It tells us, let's say it tells us, put notes together, how many times you're going to see this graph between 0 and 2 pi, okay? So let me go 0 to 2 pi over here so we can land this on a graph we know. What is pi over 2 equivalent to? Pi over 2 is equivalent to 1.57, right? So we're going to see 1.57 of this graph, so about 1.5 of this graph between 0 and 2 pi. Does that make sense? We'll round it to 1.5. So that means I'm going to see approximately, Hannah, something that looks like that, right? From 0 to 2 pi, 1.5 this graph, approximately. We're really rounding. Well, 4 then is approximately in here, right? That's where the number 4 is. So we can see one period of it. It's just a nice integer value. It's not in terms of pi. Is that clear? Good? Good? Okay. Example number 3 then. Can I erase this board? All set? Hannah, good? So here is our next example. Example number 3. So example number 3, I would like you to graph one period of y equals sine 1/2 x, sine 2x, sorry, points over there. Graph one period y equals sine 2x, and then determine the number of solutions for the equation sine 2x equals 1/2. So graph one period. I would like to use that visual of our graph to help us determine how many solutions we should have for sine 2x equals 1/2. Why don't you take 2 minutes or so, 2 or 3 minutes. You may talk to your partner, you may work on your own, and then we'll come back together. I need to change the directions on the top. Can you graph from 0 to 2 pi? Sorry. You just extend it, right? Is that okay? Sorry. Extend it, 0 to 2 pi.
Just from 0 to 2 pi, though.
Just from 0 to 2 pi.
That would be 4.
Would it be 4?
Thank you.
That's good.
Okay, so we're almost there. Your graphs look like mine, they almost all do. We're getting stuck a little bit on, once you land all of your fractions in. Okay, sometimes it's helpful to just sort of extend the first period. So we're really good at drawing a sine graph. So if I know it's from here to here, I just go like this quickly, more than thinking about all the fractions. Does that make sense? Okay, land your fractions in and then think about where your period is, how many times you're going to see it, that might be helpful. Okay? Okay, opens up and then goes down. How many answers will we have from 0 to 2 pi? We're staying within that domain. How many answers will we have? When will sine 2x equal a half? How many answers will there be? Robbie, what do you think?
4.
4. How many of us agree with 4? Yeah? Jordan, good? Yeah? Okay, so let's think about your graphing calculator. If you're going to type it in your graphing calculator, might as well connect it there. This would be y1, this would be y2. So we're literally looking to see where do they hit a y value of 1/2, and that's the same as what your graphing calculator does for you. So I'll put a star on these values right here. But I should end up with 4 values, 4 solutions. Yeah? Good? So how are we going to get there? The first solution, algebraically, right, without your calculators, the first solution is less than pi over 4. Okay, and the next solution is between pi over 4 and pi over 2. Hannah, what are we going to do? Can you wait? We need a couple more minutes. If you can wait, if not, go ahead. Okay, let's go ahead and solve it. We're going to solve it the way we've solved every other equation, and then see how that 2 plays into our answer. Okay, so let's go ahead, and if you can go right below it, let's solve it algebraically. So we have sine 2x equals a half. Okay, and I'm just going to keep that sine 2x together. In fact, I'm just going to change the variable, use a little substitution, and say that theta equals 2x. I'm going to use a dummy variable so that I can think in terms of a sine or cosine graph that I know. And so I'm going to go sine theta equals 1/2. Does that make sense? So when is theta equal to a 1/2? Between 0 and 2 pi, theta is equal to 1/2 when?
Over 6.
Pi over, not pi over 4, pi over 6. And what else? Pi over 6 and
5 pi over 6.
5 pi over 6. We'll go radians. 5 pi over 6, okay? Actually, I'm going to leave some space. Now, I said between pi over 6 and 5 pi over 6, but let's go ahead and put in the 2 pi n for our coterminal angles. Does that make sense? Because we don't know how many times around we're going to go. We want to make sure that we're between 0 and 2 pi, okay? So I'm going to add 2 pi n in both cases here, 2 pi n, to represent all the values on the unit circle, and then we'll see how much of that we need. Still with me? So I want to know not what theta is, but 2x. So let's go ahead and slide back in 2x here. So 2x is equal to pi over 6 plus 2 pi n. Excuse me. And it's also equal to 5 pi over 6 plus 2 pi n. Okay? I'm going really low. Can you guys see in the back okay? Excuse me. So I don't want to know what 2x is. I want to know what x is. So what are you going to do throughout all of this? We are going to divide by 2. So we're going to divide the over 6's by 2, but also the 2 pi n divided by 2. So we're going to do pi over 12 plus 2 pi n over 2 is pi n. Does that make sense? Check my arithmetic. Plus, it's going to be 5 pi over 12 plus pi n. Are we good? Okay. Would we put them all together? How so? No, I didn't mean to do that. Thank you. An and statement, yeah? Okay. I'm going to write up here so we can see better how this relates to our graph. So our domain is from 0 to 2 pi. We just found that x is equal to pi over 12 plus pi n, right? And we have the set of answers 5 pi over 12 plus pi n, right? Does that make sense? What's the period for this graph? The period for this graph is how much? Pi. Are you with me so far? So if we add pi to each one of these values, we'll end up with the coterminal angles. Now, Dreads, if you're with me so far? Okay. Well, our domain is really from 0 to 2 pi. We're always going to go 0 to 2 pi. That's what our graph is. We said there are 4 answers. Right now, I only really have 2, pi over 12 and 5 pi over 12. Well, pi over 12 is here, and then 5 pi over 12 is here. Now, Dreads, if you're still with me? Okay. How do we get the other 2 answers? What are we going to do to pi over 12? Add pi. So that we get to another coterminal angle. That is one complete period. So we're going to add, so our final answers are pi over 12, comma. If we add pi to pi over 12, what do you end up with? Pi plus pi over 12 is 13 pi over 12. If we add another pi, we end up with 25 pi over 12. Are you with me? 25 pi over 12 is past 2 pi, so we don't want that set. Yes? And now I'm going to go to this set. 5 pi over 12. So over here, 5 pi over 12, we want to get this answer over here. We're going to add pi. 5 pi over 12 plus pi is equal to 17 pi over 12. If you were to keep going, because you just kept going, we'd end up with 29 pi over 12. 29 twelfths is over 2 pi. How many answers do we end up with, folks? 4, right? We started by saying we would see the graph twice. We started by graphing and said there should be 4 answers. The little bit of extra arithmetic is figuring out what to do with that 2, right? Kyle?
If you asked us this question on a quiz, would you specify like 0 to 2 pi?
We are always going to assume right now it's 0 to 2 pi, every question moving forward. I think the textbook questions are all the same. So I go without 0 to 2 pi so we can put the 2 pi n in there. But every answer you're giving me, unless I change it, will be between 0 and 2 pi. Good? Questions? Okay. I think we'll end it there. That is exactly good. Thank you guys very much. If you can turn that off, then that would be great. Is it off? Thank you, thank you.